Okay, this is homework help for Math 2, Unit 12, Lesson B4 or Lesson 8, depending upon how your teacher teaches things. So here we go. This is Form K, looking at these numbers written across the top. Let's take a look at complex numbers. We're going to simplify each one by using the imaginary measuring number I to make this work. We're going to take the radical 2, and we can't obviously have a negative 2 here, so what we want to do is we're going to multiply it, change this to be 2 times a negative 1. We're going to do it that way because if you remember from your lesson in class, radical negative 1 is actually equal to I. So by doing that, we can then break this apart into negative root 2 times root negative 1. And what I really have then is I, because that's what that value is, root 2. And that's the way we rewrite that with imaginary numbers. For number 4, let's do the same idea here. We have 36 times a negative 1. Okay, and I break that into 2 chunks there. So the square root of 36 is actually 6, and the square root of root negative 1 is I. And so my answer is simply 6I. And that's all there is to that right there. I'm going to skip these ones here because I'm not sure if your teachers are going to cover this. I've noticed I didn't see a lot of coverage in other things for how to plot these out and how to find the absolute value. So I didn't see many lessons on that, so I'm assuming we skip that for this unit. Let's move on down to number 10. Number 10 says simplify each expression. This is essentially just combining like terms. I could rewrite this to start off with this as negative 12I minus 3 and distribute the negative through as a negative 3I. I combine my like terms of the negative 3I and negative 12I, and I'll put my whole number or real number in front. So the real number goes first is negative 3, and negative 12 and a negative 3 become a negative 15I. And that's all we do for number 10. On number 13, we have to write each quotient as a complex number. What it's wanting us to do here is to get rid of the negative I from the denominator. Again, a negative I is actually equal to, an I is actually equal to radical negative 1, and we can't have a radical in the denominator. So to solve that, I'm going to multiply by 3 plus 2.I. Okay, and we call that thing the complex conjugate, which is basically take the negative, make it a positive, and I'll multiply the top by the same thing, 3 plus 2I, right there. At this point now I have a lot of things to distribute and rewrite. So I'm going to distribute this here as negative 1 times 3 is negative 3, negative 1 times 2I is a negative 2I, and then here I have a 5 times 3 is a plus 15. Plus 15I, and 5 times 2 is plus 10I squared. On the bottom, I have 3 times 3 is 9, 3 times 2I is a plus 6I, and that becomes a minus 6I, and that becomes a minus 4I squared. To rewrite this here, and I'm going to go ahead and slide over to the side a little bit. I like to go this direction. Combining my like terms, I have a negative 3 stays where it is on the top. 2I and a negative 2 and a plus 15 makes a negative 13I. And this 10 becomes 10 times negative 1 because I squared is equal to negative 1. Just another thing you have to remember there. On the bottom, we have 9 minus 4 times I squared. Again, these cancel out, and I squared is negative 1. So rewriting this again, negative 10 and a negative 3 is a negative 13 minus a 13I, and on the bottom, 9, well, negative 4 times negative 1 is positive 4, and 9 plus 4 is 13. I could reduce all this, and this becomes negative 13 over 13, which is negative 1, and negative 13I over 13 becomes, oops, I have a positive there somewhere. Should be a plus I. Okay, let's see where our little plus went. Right here. This right here, made a little mistake. 15I minus 2 should become a plus 13 for a plus I. That's where I messed up there. That's number 13. Let's flip it over the back side and look at these. Solving each equation. The way we go about solving these equations is, if you recall before, if I was to take this and break it apart into two factored terms like this, I could break the x apart into x and an x, and 4 becomes a 2 and a 2. But if I just left it like this, I would end up with a 2x and a 2x combined to make a 4x. Or I really couldn't make 0x because then I wouldn't get a positive. If I put this as a negative and negative, I would get a negative 4x in the middle. So in order to make sure that I don't have any middle terms here, 4x, what I want to do is multiply or take my last value and turn it into an imaginary number. So now if I was to distribute this out, I would have x squared, so I have plus 2i and a minus 2i, so x minus 2i. I would have x squared, and then I would have a minus 2i plus 2i, and then a minus 4i squared. And these obviously are going to cancel out because the negative and positive go away, and I'm left with 4x squared minus 4i squared. You might say, well, that's a minus. Well, it is, except that I squared is negative 1. So negative 4 times negative 1 is going to equal a positive 4. So I'm back to where I started. So let's take a look at this one real quick. Same idea. First, I'm going to factor out a 3 of the whole thing. So I have x squared plus 1. And again, the idea is I'm going to take the x squared plus 1 and break that apart, factoring like this, to have x plus I and x minus I. And that's all I'm going to do for that one there. So I just took the 3 out and factored it, and I have x squared plus 1 remaining, and then I factored that to x plus I and x minus I. Looking at number 19, the same idea is in fact here. I have two squared numbers. 9 is 3 squared, and 49 is 7 squared. So when I break this apart, I'm going to have 3x here and 3x here, and I have a 7i and a 7i. One is positive, one is negative, and that's all I'm going to do on that one there. Okay, so let's do one final problem, number 23. First thing I need to do is distribute this x all the way through and rewrite this as x squared minus 3x plus 3. It wants to use the quadratic equation to solve all of this. So I need to know my a value, my b value, and my c value. My a is 1, my b is negative 3, and my c is 3. So I rewrite this now as negative b, and b is negative 3, so negative minus a minus 3, plus or minus the square root of b squared, negative 3 squared, minus 4 times a, which is 1, times c, which is 3, all over 2 times 1, which is a, which is 1. This becomes rewritten as a positive 3 plus or minus the square root of, this is 9 minus 12, which is a minus 3. So now we have this negative number underneath the radical, which we really don't want to have. So that gets rewritten for now as 3 plus or minus negative 3 over 2. When we look back at kind of what we did on the first side, to get rid of that negative, we break it apart and make it into 2 times a negative 1. In this case here, this becomes 3 plus or minus, and then the way we make this work is it becomes imaginary root 3. And that's by turning that negative root 3 into 3 times negative 1, and then keeping that there and turning that into the I. And that, of course, is over 2. And that's all we have. That's our crazy number here. So you have 3 plus or minus I root 3 over 2. Alright, and that's it. Hope that helps you out.